All across the world, we are seeing the rollout of vaccines, and in some cases, I guess you might call them prophylactic treatments, in that they don't necessarily prevent transmission of COVID-19. Well, there seems to be two sides to this debate, and that's quite a shame because it's not a binary issue. There seems to be one side which is everyone must get this vaccine right now, and there seems to be another side saying no, vaccines are terrible. Well, I'm very, very pleased and honored to have an expert in the field on the show today. His name is Geert Vanden Bossche. He is very, very experienced in the design of vaccines and has been doing this for decades. He's held multiple different sort of positions amongst industry creating vaccines, not-for-profits, as well as in academia as a professor at different times. And he has been publishing something lately. I guess you could say he's raising the alarm. He's raising the alarm on something we're going to talk about during this interview called immune escape. But really, at the end of the day, he's calling for us to stop. Can you believe this? Stop mass vaccinating around the planet today. So, Geert, welcome to the Discernible Interviews, and thank you for joining us.
Thanks, Matt. Thanks for having me.
Geert, let's start from the beginning. We have something going around the planet now called COVID-19, a coronavirus. I don't understand why you are so alarmed at, I guess it's because I don't understand this concept of immune escape. Do you want to start us off with really what is the very core of your worry here with immune escape through, I guess it's through over-vaccination or vaccine resistant phenotypes developing?
Well, Matt, let me try to explain this in simple words. There is a kind of general principle in, I would say, in biology, certainly also in vaccinology, in microbiology. And that is that if you put a living organism, like especially bacteria or viruses, under pressure, whether you do this by antibodies or chemotherapeutic or antibiotics, it doesn't matter. You put it under life-threatening pressure, life-threatening to the microorganism. And you do this in a way that you still allow that microorganism to replicate to some extent. Of course, it will have a very tough time because you're threatening it, and a lot of these microorganisms will die. But if you cannot really kill them all, let's say, if you cannot prevent completely the infection, and if there is still some microorganisms that can replicate despite this huge pressure, they will start to select mutations that enable them to survive. So what does that mean, selecting mutations? Well, these microorganisms, and especially as we know also COVID-19, has a high capacity for mutation. So these folks are mutating all the time, and if they are not under pressure, if they are not under pressure, they don't see any need to select specific mutations to become, for example, more infectious or what. There is no need to do that because they are just fine. But if now you start to put some pressure, whether this is by drugs or, as I was saying, antibiotics in case of bacteria, of course, not in case of viruses, or our natural antibiotics, our natural antiviral antibiotics, these are, so to say, the antibodies that you develop when you are, for example, immunized, be it by a natural route, for example, through natural infection or through vaccination. If you put these guys now under pressure, they can choose amongst a multitude of mutations, and they will select those mutations that enable them to survive.
Okay, so let's...
No, I need to continue this, because this in its own right would not be a disaster, certainly not for viruses. Why? Because as we all know, viruses can only multiply, replicate in living cells, okay? So if these guys, if they are released from the cell and they don't find another living cell pretty soon, because as we know, COVID is an enveloped virus. It cannot survive for a long time in the environment. So it's critical that the guys who have been selected and the selected mutants find as soon as possible new living cells, so a new host that they can infect. And that is especially the case when you have a pandemic, because there, the virus is all around, the infectious pressure is so huge, the virus is almost like everywhere, that it's not difficult for the virus to find another living cell or organism where it can replicate. So it is very, very similar what's happening, the immune escape and all this, complex. Well, people are nowadays should be very well aware of antibiotic resistance, right? Yes. This has been a huge debate over the last 10 years. It's exactly the same. When do you get antibiotic resistance? You get antimicrobial resistance when either you are not using the adequate antibiotics. If you are prescribed the wrong antibiotic that does not match really with the microorganism that is infecting you, it's not going to work. That's the reason why we make, if we have a bacterial infection, we don't know really what bacterium is involved. What we are going to do is, of course, make an antibiogram, right? And then we will know, okay, it's this type of germ. This is the type of antibiotics we need. So that is one thing. That is one reason that could cause antimicrobial resistance. And I will translate this in what that means for the virus. Just 1 second. The second cause, of course, very important, of antimicrobial resistance is if you don't take your antibiotics as long enough as the prescription indicates. Because then you may, after 3-4 days, you think, wow, I'm feeling well, and you stop the antibiotics, but there is still a few remaining germs, and they will cause a flare-up, right? So what does it mean in terms of the virus of COVID immune escape? Well, we can exactly transpose this on COVID-19 in the sense that if we have, for example, now, as is the case right now, today, many variants circulating that are more infectious. We have a lot of variants in the meantime that are circulating, but we are still, in the vaccine, we are still having the original spike protein of the original circulating strain. And of course, that doesn't match very well with the spike protein that is now presented with those variant strains, because the variation is exactly or primarily in the S protein. So there you can see already, we have antibodies, but they don't really match very, very well to the circulating strains. Just like the antibiotics, were not really well suited for the bacterium. The other thing is that if we have, for example, now we are vaccinating people in the midst of a pandemic, what does that mean? Well, many of these people are mounting antibodies on a background of circulating virus. So that means I always compare this. if you go to war, you better make sure that you have your weapon already prepared before you go into the trenches, right? I mean, if you are still loading your weapon whilst already being under attack, then you have, of course, you are in a suboptimal situation because the antibodies are still not mature, the level is not high enough, and you are already under attack. So the virus will take advantage of this suboptimal immune response to escape to this immune response. And during this pandemic, we have several different situations where the immune response is suboptimal. I just mentioned one. I will mention a second one, which is typically, you know, Matt, many or several of these vaccines, the majority, in fact, do require 2 injections, right?
Yes.
You have your, and then you need a boost, and there is, yeah, depending on the vaccines, there is, you know, 2, 3, 4, 6 weeks between the 2 injections. So that means that a number of people, many people right now, are still, you know, in one single injection. And so they have not an optimal immune response right now. And they are already exposed to the circulating virus, which is everywhere and which has become more infectious. So that is a situation where the antibody response is suboptimal. The third situation where the antibody response is suboptimal is in asymptomatic carriers. So I explain, these are people who get infected with COVID, but do not show any significant symptoms. They may have some mild symptoms, upper respiratory symptoms, or they have no symptoms at all. And those guys develop, they will eliminate the virus just after like 1 week, but they will mount a little bit of antibodies, a little bit. But this is also suboptimal, and it's very short-lived. They will decline very rapidly. If they get reinfected during this time where they have their suboptimal antibodies, this gives again an opportunity to the virus to escape to the immune response. So in other words, to make very complex things very simple, because of the pandemic, because of the high infectious pressure, we are having continuously situations where the virus is confronted with suboptimal immune responses, and that gives the virus plenty of opportunity to escape, to select mutations, to become more and more infectious up to a point, and frankly speaking, I think we are extremely close to that point where we will have full resistance to the vaccine. But it's not, in fact, the end of the story. But I will just leave it
we'll get there
for a moment to you to, yeah.
We'll get there for sure. So just to get the background straight, when you talk about viruses coming under pressures, mutational pressures or evolutionary pressures, in a pandemic, we have these suboptimal immune responses that you referred to, and you're saying that is worse than if there was no pandemic. Like a normal seasonal flu does not come under the same evolutionary pressures. Is that right?
Well, yeah, I mean, a big part of the problem is that we are under attack all the time. I mean, the pandemic started, roughly speaking, 1 year ago, even over 1 year ago. And I mean, per definition, pandemic it's everywhere. It's global. And, you know, the infectious pressure becomes always higher because now we have infectious strains that are more infectious, much more infectious than the original strain, in fact.
Yeah.
So that is the problem. We are under attack all the time.
Yeah, but they only exist because those pressures have been placed on them. They've been forced to develop a more infectious strain. For example, do you know much about the Brazil strain that was reported in Science journal? They're saying that strain developed without those pressures. It popped up in the wild. Does that make sense to you? A new strain in Brazil without those?
Well, let's distinguish between two things, because here I'm purely following. I mean, I'm not an expert in analyzing all these mutations. I mean, these mutations, it's like every day. What I'm following is the basic laws of biology.
Right.
And I mean, the highly infectious strains that we are seeing right now, or that we have, you know, they started to pop up end of last year, right? This was definitely way before the effect of the mass vaccination became visible. Yeah, because even right now in many countries, like in my country, we are having a coverage, I think, between 4 or 5% right now. In other countries, is even less.
Yes.
So the appearance of these highly infectious variants is not related to mass vaccination.
Really?
So what it is related to is another dramatic human intervention, which were, of course, all the infection prevention measures and all the containment measures, where all of a sudden the virus comes under tremendous pressure. Because I was saying, these guys need living cells. And if you restrict the contact, and if you restrict the probability that they're going to get in contact with a living organism because, you know, of all this infection prevention, I mean, it's the word itself says infection prevention measure, then it comes under tremendous pressure. So then it will exploit every single situation, you know, to become, in fact, more infectious. And can you explain this in more detail, if you like, how this works?
Well, just on this point, Geert, are you advocating, because you're talking about lockdowns placing mutation and evolutionary pressure on the virus to become more infective or what have you, are you suggesting we should have done the opposite of what most people around the world today think infection control? Are you saying we should have let it out a little bit more, to let it loose a little bit?
Well, you have to be very careful here, because when people interview me and they start out, telling, well, Geert, are you against these lockdowns and we should go the pandemic run, etc., run its course, etc.? The first thing I'm saying is that it's so critical that we understand what the natural, without human intervention, what the natural course of a pandemic is. Because of a pandemic, of an acute viral infection. I'm not talking about HIV, etc. I'm talking about, for example, COVID. I'm talking about pandemic of flu or enterovirus or epidemic. And then you will realize that the evolution and the co-evolution of the pathogen together with the immune system of the host has been such that, as a matter of fact, the toll taken on human lives and disease is restricted to the absolute minimum for the virus to be able to survive. So it's not the toll that we, and I will hopefully explain in a minute, the toll that we are now going to have to pay, the price is just tremendously more. But to your question, there is one component has been completely neglected in this, in the consideration of how do we treat the pandemic, how do we go about this, and that is the most important component of the immune system, which is the innate, with regard to COVID, okay, is the innate immune system. We have an innate immune system that, especially in young people, in children, children barely get any disease, is very strong, is very well developed. As we grow up, as we get in contact with more and more germs, as we get also diseases, all kinds of diseases, we start to develop specific immunity, specific antibodies. That is not innate, that is acquired. That is the other arm of the immune system. And as this evolves, the innate immune system, the defense against a specific pathogen or against pathogens, gets increasingly eroded at the advantage of the acquired immune response. So the innate immune response is very, very important to realize this. We call this polyspecific. It's not specific for a single pathogen. For example, in case of COVID, the innate immunity that we have is active against all coronaviruses, right? It's not just COVID or its variants or whatever, all coronaviruses. So that is fantastic. And it's especially in younger people, it's very well developed, or people who are really in very good health, could even be people 80 years old. They are in good shape, in good health, etc. But Matt, the important thing to realize is that what is the single biggest disadvantage of this innate immune system? This innate immune system has no, we call this immunological memory. So this is to say, the acquired immune response, if you have seen the pathogen, your immune system, will induce B cells, T cells, and those guys acquire a memory. This is to say, next time when the pathogen comes in, they have their arms already, ready to go. So they can immediately attack it and destroy it.
Yeah.
The immune system doesn't have this. So what is really critical, which is critically important, is that in order to keep your innate immune system in good shape, you need to keep it well trained. So that is to say, Matthew, if you're going to sit on your chair, on your seat for like 3 weeks, you're going to see that your muscles are going to wane. I mean, your muscles are going to shrink. Yep. So you need to train, you need to exercise. And what is this exercise for the immune system? This is simply to get exposed to all kinds of foreign influences in the environment, etc. So what have we been doing at the beginning of the pandemic? To a large extent, I don't know how the situation was in your country, etc. But and it has been dealt with in different ways in different countries. We have been closing schools, we have been closing universities, we have been telling to our kids, don't get too much in contact with those and those guys. And I think this was completely wrong. Of course, I've always been, even regardless of the pandemic, I've always been against this mass convenings, mass gatherings where you have thousands and thousands of people, in one small place. My background is veterinary medicine. We know in industrial farms where you have a high stocking density of animals, like, for example, pigs or poultry, I mean, they are extremely susceptible to getting diseases, of course. This is because just of the, huge density. But what has happened during these lockdowns is that, of course, a lot of people who had a very good innate immune system, they lost their training. The innate immune system didn't get trained any well, and that, that was something which was certainly not very favorable in terms of their immune defense in general against COVID.
So is it fair to say that we should have stopped large gatherings and so on, but we definitely should not have completely isolated our entire population, such as Australia and New Zealand, where I am in Australia? We are so isolated that we have no cases. And that's politicians say that's wonderful. But some of us are fearful that we are so isolated that we've had zero exposure, that when we do finally become exposed, we're going to be very, very susceptible.
Matthew, I mean, your wording is just 200% correct. I mean, of course, the countries and the continents that think they are going to solve the problem by full isolation or by doing immediate lockdowns, like, for example, in China, you have a case and immediately 100,000 people get locked up. You can do this, provided you accept to stay isolated
forever.
So that means, what about trade? What about tourism? What about exchanges, etc.? Because as you were pointing out correctly, you will be extremely susceptible, of course, to the disease.
Can I ask you? Okay, can I ask you a hypothetical, from a scientific perspective, before we move on to what's the bad things that are happening? What could they have done better, scientifically speaking? Say here in Victoria, a state of Australia, we had, I think it was 3 cases and it went to 8, all within a hotel quarantine system. And we locked down 6.4 million people for 5 days. And in one of our other states, Western Australia, we locked up the entire state. I think there's about 4 million people in that state for one case. Well, not even a case, one positive PCR infection. What should we have done, scientifically speaking? Should we have locked down at all? Should we have I don't know. How should we approach that?
Well, it depends on what the overall strategy is. If the strategy is, we absolutely want to avoid any case of disease or lethality, fatality, that's what you need to do.
Okay.
But, if you think at a population level, because I mean, we are very, very focused on the individual level, and we are very much focused on the short term, right?
Yes.
So that is also what the vaccines do. So sorry to come back just for 1 second to the vaccines. Are the vaccines safe and efficacious? Certainly, if you look in the short term, and if you look at an individual base. If you look at the population level, there is two things that you can do. Either, and I mean, it sounds pretty cruel what I'm saying, and I'm not advising this, I'm just saying what are the theoretical possibilities. One is you let the pandemic run, but of course, you take care as good as you can of the people that get a disease by proper treatment, by better studying how to control and how to manage this cytokine storm that ultimately people fall victim to. That is one situation. And then, of course, you will have a pandemic, which is typically in 3 waves. And, that is what I'm saying. Yes. People should first understand how a natural pandemic, what is the natural course of a pandemic? Because if you don't understand this, I would say you have no right to speak. It's as simple as that.
Should we do that now? Shall we talk about the 3 stages, which is in every pandemic?
Yeah, we can do this, Matt. So I was just saying the other solution is to use and to implement an immune intervention that is not subject to immune escape. And let me just, because I think along the lines of what we are discussing right now, it will be more understandable for people if I explain this right now. And there I was always saying, well, it's a fantastic example on how we should do this. Because many people, they get the infection, but they don't get the disease. And what we see is that after like 1 week, they completely eliminate the virus, right?
So, sorry, you cut off. Did you say what is a really good example? Did you say a country or?
No. I say the virus itself is giving us the example on how we should intervene in a way that does not allow for immune escape.
Okay.
And that is the example, or the people that are asymptomatically infected, okay? Right. Because they eliminate the virus after like 1 week, so the infection gets completely abrogated. And interestingly, nobody seems to pay attention to this. This is not due to the antibodies, because these people develop a little bit of antibodies. Well, I mean, can be a reasonable amount of antibodies, but never titers as high as people who get symptomatically infected. And those titers are very short-lived, second. And third, this surge of antibodies comes more or less after, the virus has been transmitted and eliminated. So this is to say that these antibodies cannot be responsible for elimination of the virus, right? Because they come too late. Okay. So the mechanism, and I posted a number of slides on LinkedIn and Twitter, etc. The slides of my presentation at the vaccine summit at Ohio, that there is now compelling evidence that these cells, that the virus get eliminated by NK cells, natural killer cells.
Which is your innate immune system.
Exactly. Well, the innate system, is the innate immune system? Who is taking care of the virus in terms of innate immune system? These are our innate antibodies, natural antibodies that, we get at birth. Is a very well-established system, but it needs to be trained, as I was just saying, together with the natural killer cells. So these guys are capable of eliminating the virus without leaving the virus an opportunity for immune escape. And so if you're asking me, getting back to your question, what are the 2 solutions? Either we outsmart the virus. That's not what we are doing right now with the current vaccines. We outsmart the virus by using its own trick, so to say, against it, against the virus. Or we have to accept that we go through a natural pandemic where we will have a number of casualties. I'm not hiding this, but the toll taken on human lives will be dramatically less than the price we will pay right now. Because frankly speaking, what I'm telling is that the pandemic still has to begin. A huge wave still to come. We are at the eve of a tsunami, and I'm not. Yeah.
Okay, let's talk about this now at length. So to get into this, just want to make sure I confirm with you. You do believe, is it true that the vaccines that we have now, they are efficacious on an individual level, but you're saying on a population level, what we're doing is we're going to create a much bigger problem? Is that right?
Well, they are efficacious for now, as long as we don't have resistance. But what we are forgetting, Matt, I mean, very simple. I told you before, we started the show, so to say, that I would make some shortcuts or explain things a little bit more easy.
Yep.
Initially, you have, of course, like if you have people who are infected normally during a natural pandemic,
yes,
the virus jumps from one population to the other. What I mean is it will first attack, of course, the people who have very weak innate immunity.
yes.
Why?
Yes.
Why? I mean, if the virus is new to the population, right, there is no acquired immunity. There is no antibodies, of course.
Yeah.
So all you have is your innate immune defense.
Yeah.
So those folks who have a very strong innate immune system, I mean, they're just laughing about it. They're just going to have, sore throat and or maybe no symptoms at all. But the people, and we know those people, of course, elderly people with underlying diseases, etc., and not, or otherwise immune compromised people. Those are the people who will, of course, suffer from the disease. But then what happens is that once this reservoir, I would say, of susceptible people get a little bit exhausted, the virus has no choice but to look for other victims, right?
This is another pressure. This is bad.
Yeah. But look, this is the only thing which is a little bit complicated to understand, and I will do my best to explain it because it's so critically important.
Mm-hmm.
So now you imagine, I just told you, if people with a good innate immunity, right? So the asymptomatic people, right? Okay. If they get infected, okay, they will have for a very short time a surge in antibodies. Okay, for a short time, a week, 2 weeks. I'm not discussing about days because other experts know this better than I do. So and this is the single most important thing that I would like to convey. These antibodies, although they are not important in terms of protecting that individual, because I just told you, it's not the antibodies that clear the virus, it is the innate immunity like the NK cells.
Yeah.
What they do is a very nasty thing. They will outcompete the natural antibodies for binding to the virus. So what I mean with this is normally, if you don't have these specific antibodies, your natural antibodies will capture the virus and they will eliminate it, or they will introduce this into the pathway where the NK cells can kill the cells that virus infects, right? So now if you have very specific antibodies, they will say to these natural antibodies, no, your affinity, which is true, your affinity for the virus is way too low. And indeed, natural antibodies, they are multi-specific, okay, but they have lower affinity than the specific antibodies do, okay? So even though, for example, specific antibodies don't recognize the virus very well because it's a variant, for example, and the antibodies were originally raised against the original virus, they will still be capable of outcompeting the natural antibodies for binding to the virus, right? So that means every single time that these asymptomatic patients, or these are not patients, asymptomatic subjects have this short-lived surge in antibodies, you get a suppression of your innate immune response. Are you following me?
Yeah, I am.
So now at the beginning, There is no problem because, I mean, these people have this surge in antibody, they have a suppression of their immune system. But at the beginning of the pandemic, I mean, the infectious pressure as the virus is not spread like very broadly, the likelihood that a person that just happens to have this surge in antibodies encounters the virus is pretty remote. Is that clear?
Yes.
So now, as the infection spreads, I was telling you, the first wave, these are the folks that have a vulnerable innate immune system, okay? Yes. They get infected, but that reservoir gets exhausted. But at the same time, the virus pressure increases. So the likelihood now that somebody which has a good, strong innate immune system, especially the youngsters, happen to have this surge in antibodies, and exactly at that time gets reinfected with the virus increases. Shall I repeat this?
And then also their outcomes will be far worse on the second time round.
Well, why? Well, I'm just saying these specific antibodies, they suppress the innate immune system. And the innate immune system is the single most important defense of these youngsters, right? So now they get all of a sudden a transient, momentary suppression of their innate immune system due to this momentary raise in the specific antibodies, right? And the likelihood that exactly during that time they get infected is much higher, of course, if the infectious pressure and the spread and the pandemic, is already well established. So now you get the youngsters that are getting the disease, right? Because their innate immune is suppressed. And that is exactly what the virus wants. The virus is not interested in infecting you in an asymptomatic way, because then the virus replication and transmission is limited, as I just explained. But if you get a disease, you're going to shed the virus for a long time, for a prolonged time. So now you get these people who get infected. And what we are doing right now, coming back to lockdowns and infection prevention measures, etc. Normally, during a natural pandemic, Matt, the virus will feel no pressure to select mutations. Why? Well, I'm just telling the youngsters, their innate immune system gets suppressed. And of course, there is only a limited reservoir as well of youngsters that will be susceptible to the disease. So this reservoir gets exhausted, but by the time it gets exhausted, the first group, their antibodies will start to wane, right? The first group, these people with weak innate immunity, they mounted, those who survived, of course, they mounted antibodies, they were protected against disease, but that immunity starts to wane, right? Now the virus just jumps back to all the folks that are seropositive or were seropositive, because the antibodies start to wane. And so what do we have? We have a fabulous thing. I mean, this is just, the beauty, in fact, of nature. This strain doesn't feel any need to become more infectious, because at any time in the pandemic, it finds a susceptible, a population, a subpopulation that is susceptible to the disease, right? You understand what I'm saying?
Yeah. So but then what happens though? Does it die out slowly as it jumps between populations?
Of course. Why? Because, so then I was saying, you're going back to the first population, right? Those who were seropositive. And then, of course, they get reinfected, not all at the same time, of course. But remember, they have now acquired immune responses.
Yes.
So they have memory. So as soon as they get infected, they mount their antibodies immediately. And then the youngsters who got the disease are starting to doing the same. Yep. So what do you get here? And this is incredibly important. That is what we wanted to achieve with the vaccines, and which is completely failing: herd immunity.
Herd immunity. Yes.
Do I need to explain this? Or the vast majority now of the people are protected. What we're doing with the vaccines right now, and that's why I really don't get it. The end game was herd immunity. Herd immunity means, I will still repeat it, my own words for everybody to be clear about this, is that you protect the majority of people and you try to prevent or to reduce the shedding and the transmission as much as you can, so that the 10 or the 20 or the 30% of the people who are not vaccinated, who have not been naturally infected yet, they are not infected because the chance of the transmission to them is too low because there are too many people protected. But what we do right now with the vaccines, and especially now that these highly infectious strains or variants, I should say, are circulating, is that we come with vaccines that can no longer fully protect. People are still protected for now against disease, against severe disease also, but they are no longer protected against shedding and transmission of the virus. So, and we see that people get vaccinated and they are still shedding virus, maybe less than, you know, people who get, or people who mount homologous antibodies, but still these variants are able to a large extent already to escape to the immune response to an extent that they can now shed a virus. So instead of generating herd immunity, we are doing exactly the same, because these folks now become asymptomatic carriers. We are turning these people into asymptomatic carriers that, well, asymptomatic carriers if they get, of course, exposed to the virus. But they will get exposed because I'm saying we are in the midst of a war with increasingly infectious variants circulating, right? So the likelihood that these people get infected is pretty high, and they shed the virus and they transmit it. And the people who are not infected, they are not aware. These people are vaccinated. They think they are protected. They have no symptoms, of course. And that is part of the disaster that is going. Because what is the end? The end game was herd immunity, right? You agree with me? This was the purpose of the vaccination. And we will just doing the opposite. That there is no talk about herd immunity. So what are we doing?
So you just explained herd immunity quite beautifully, but can I ask, how long are those time frames, jumps between population, and you develop herd immunity? Are you talking about weeks, months, years in a normal process?
During a natural course? Well, yes. I mean, the example that was best documented is, of course, the flu pandemic of World War I. I mean,
Spanish
you
flu.
may know. Well, the Spanish flu, but the flu was everywhere. Just that there was military censoring of communication. So, of course, enemies would not say or would not communicate about the thousands of deaths they had. And so only Spain, which was independent during World War I, was communicating this. So that's why it was falsely called the Spanish flu. But remember, I don't know if you have ever heard this, but this is very well known, that many more soldiers died in the trenches of flu than of wounds and injuries, war injuries, actually.
Yes, but Spanish flu was over. That was finished within less than 12 months or less than 18 months, right?
Oh, yeah, sorry. I should respond to your question, of course. Well, the whole pandemic was, if my recollection is correct, about 2 years, something like this. And you had the 3 waves with some kind of, I would say, infectious, I call this infectious quiescence between the waves, right? It was, but then you develop herd immunity. And then, of course, from time to time, the virus will find some more vulnerable people, or in some populations, in some countries, in some regions, the immunity will wane a little bit too much, and then the virus will kick in again. But you have a lot of memory, that will immediately, again, dampen this viral infection. So you get these surges in between, but you never get back to a pandemic, of course, right? Because now the population has been immunized, so to say, in a natural way.
Okay,
with
so
memory,
now
immunological memory.
Right. So now we are vaccinating people with vaccines that do not prevent transmission. They simply prevent symptoms. So we're creating asymptomatic carriers, as you said. Is the main danger there that it is adding increased pressure onto the virus to mutate? Is that what the problem is?
Well, as I was saying, Matt, as I explained at the beginning, we have a number of situations where the virus is, encountering an immune system that is not very well armed. where the immunity is suboptimal, and especially also when we vaccinate, right? But even during natural infection, the natural course of the pandemic, as I was just saying, the situation where asymptomatically infected people have this surge in antibodies and it suppresses their innate immune system. Well, these antibodies, as I was just saying, they are not really optimal. They're short-lived. They didn't get a boost, etc. So that's a suboptimal situation. But if the virus can anyhow easily spread to the next population, in that case, those who have waning antibodies from the first wave, there is no need for the virus to take advantage of that situation and to start selecting very specifically, selecting mutations. If we now put the virus under tremendous pressure by doing by implementing these stringent infection prevention measures, then we are, of course, in another situation. The virus will say, well, I need to become more infectious. It's even getting worse, of course, if we now start to vaccinate all the elderly people, all the vulnerable people, because then the virus can no longer jump to that population, right? They are protected. So what it will do is it will take more and more advantage, of this suboptimal immune situation in the youngsters to select mutations that makes it more and more infectious so that it can cause more and more disease in the youngsters, right? So that it can fully exploit this system. And that is the wave that, in some countries, I tell you, frankly speaking, you have seen the figures in the UK, you will see them in Israel, where they got, so to say, a dramatic drop in cases, right?
Yes.
I will tell you, in the next few weeks, you will see a dramatic increase. That is the backlash.
Okay, so let's talk about what's going to happen, because you said there are two ways this could go. You can either outsmart the virus, and we'll talk about that at the end of what we should do, or we could go through an actual pandemic. Can you paint that picture for me? What are we about to see?
Well, Matthew, the situation becomes, of course, increasingly complicated and risky to let the pandemic run its course. And you will very easily understand why that is. We are no longer dealing with a mildly or reasonably mildly infectious strain, as it was the case at the beginning. We are now dealing with a number, all these emerging highly infectious strains with, a number of mutations in the spike protein that is responsible, of course, for attaching to the receptor. And we see in all these strains that the mutations are more or less converging to a set of mutations that enable enhanced infectiousness of the virus. So now it's not easy to just let run the virus, because we may hope that our younger people have still a very good innate immune response. But remember what I was saying, that is not that much a problem. The problem is that also now their likelihood of getting a momentary suppression of their innate immune system at the same time that they get infected becomes increasingly high, especially given the fact that the viruses that are circulating like right now, the variants, are more infectious, right? Do you get it? There is really logic in this thing, and that's why I'm saying, if all these recommendations and all this reasoning about the curves, where people are looking at those curves like at the stock exchange market, right? Well, it's increasing, it will probably drop. Oh, it has dropped, it may raise again. I mean, these people you have no right to speak if you don't understand, to begin with, the natural course of a pandemic, because only then you can assess what the huge impact of human intervention is. One, the strict prevention measures for everyone. Second, of course, the mass vaccination, where we are continuously loading our weapon while already being attacked, and the virus is just laughing about this. And it goes very fast. A virus replication cycle, it takes about 10 hours.
10 hours,
right?
Yeah. And I should also mention that there is an increasing there's a gap between the two doses increasing in countries around the world that are rolling out the first dose as quickly as possible. So we're effectively doing that half course of antibiotics and putting a lot of pressure on that.
These people should be put in quarantine, in fact, because they are very, very susceptible to promoting immune escape, of course, right? And we just send them back into the heat of the battle, right, where they get exposed to highly infectious strains, right? And then people, because the problem, Matt, and I'm glad you started the talk with this about these two camps, people who are excited about vaccination, those who are not excited. It depends on the way you look at it. If you don't look any further than the end of your nose, you can get very excited about these vaccines. Look, we are vaccinating elderly, and no more hospitalizations, and those folks, they don't get the disease anymore. But we forget, we are not used to thinking at the population level. What is the impact of immunizing them? And what is the impact? What's going to be the impact on the virus that is now sitting, at least in several countries in Europe, increasingly in the population of the youngsters, right? It cannot escape from that population, so it needs to increase its infectiousness, right?
So what are we going to do? Because we're vaccinating almost 1 million people per day in the US and huge numbers in the UK. What's going to happen in the next few weeks and months?
Well, I mean, at the beginning of our talk, Matt, I don't know whether we were already, no. It was already recorded, but I told you that, frankly speaking, I'm a very serious scientist. I've dedicated 20, 30 years of my life to biology, to vaccines, immunology, infectious diseases, etc. And I'm, thanks God, independent. I'm telling you that we are at the eve of a huge disaster, because the pressure that we are now exerting on the virus with those vaccines is just tremendous. Remember, we are not doing this like progressively. We are talking about mass vaccination, vaccinating millions and millions of people in an as short time period as possible. Can you imagine? And we think we can outsmart this virus. Come on. And we think we can make new vaccines against the variant strains. The virus is not going to wait till we have those vaccines ready. And so it's very, very clear. I know my message, people will maybe think I'm crazy, etc. But I think there is such compelling scientific evidence, right, to really conclude. And I invite, because I have been asking scientists, health authorities, to please start a debate on immune escape, but nobody is reacting. There is silence all over the place. But you see this paper still this morning, I was reading a paper somebody sent me, that now the immune escape is even expanding to other regions than the spike protein. That also when people who get a disease and ultimately recover, they recover to a large extent, not thanks to the antibodies, but thanks to the cellular immune responses. Now the virus, being put increasingly under pressure, is starting to introduce critical mutations in epitopes, antigens, that are responsible for inducing this protective cellular immunity that comes later, of course. And that's how people, to a large extent, can recover also from the disease. So it is, we cannot imagine this virus can mutate like hell, but normally it doesn't matter, because if it doesn't select specific mutations, right, to bypass the immune system, because there is no need for, then who cares, right? But now it's not doing it. It's doing this in a very, very selective way.
Okay, we can test your hypothesis by watching, because look, the sad reality is, no matter how many people you interview with, governments around the world are not going to turn around in a big way, and they're going to continue vaccinating as many people as possible without sterilizing immunity, right? Now, to test your hypothesis over the next 4 weeks, what would prove your hypothesis correct?
Well, Matt, it's very easy. I just give you the answer.
Young people would start to be infected symptomatically.
Very easy. Which countries would you think are most susceptible or most likely, I would say, to see this dramatic evolution occur?
Israel, USA, and UK.
It's of course the countries that have, been most successful in implementing mass vaccination to an extent that already right now they have large coverage, huge coverage, and you see the drop, in infections, right? These people are excited. Look, the vaccine works, etc. That is what I'm saying. And now then you will see some silence because the virus, of course, is suffering. The virus is suffering because, thousands, millions of people get vaccinated within one country all at the same time. It's a tough time. But, the backlash will just be enormous. And these are the countries where we will most likely see first that despite increasing vaccination coverage, we see dramatic things happening, right? But of course,
symptoms, cases.
Of course. I mean, severe disease, the virus, the more you put the virus under pressure, the more it is fighting to make people ill. Severe disease is the most profitable way for the virus to ensure its propagation and perpetuation, right? Because then people shed for a long time, and they shed also a lot of viruses.
Well, so not too severe.
Sorry, please.
Not too severe, right? Because if it was like Ebola, where it's incredibly deadly, it would burn itself out. So we're not going to see Ebola.
Yeah, but as what I was just saying, Matt, the thing is, the difficult exercise for our brain is that we always think that these things are static. We have now the highly infectious strains, and okay, we are dealing with 3 or 4 strains, and no, these things are evolving. I'm just telling you that there is now mutations occurring in critical epitopes that facilitate, that enable cellular immune responses. If those also get increasingly, implemented, and of course, these highly infectious strains, there is a scientific explanation to also explain why they are so dominant, why they give no chance whatsoever at the original strains. They have an increasing, advantage to replicate. They become increasingly dominating. If that happens, that means that people who are severely ill, they are also losing an important part, of their final immune defense, their last resort, right? So I'm not saying, I'm not excluding, I'm not ruling out that we could get much more severe disease, and I'm not telling this because I take pleasure in things like this. This is just extremely dramatic. It's not static. The more we put pressure without eradicating the virus, the more it will escape, the more it will find ways to make people, ill and maybe to cause more severe disease. So, and it's not about me having be proven wrong or right. I mean, it's not about me. It's really about humanity, about humankind. I mean, I'm not saying, okay, guys, look at those curves because you will see I'm right. No, I mean, it's the first time in the history of mankind that we are intervening in such a massive way in a pandemic that has never, ever occurred before. Now, there is at least somebody, who stands up, provides scientific evidence, and, gives a very, very serious warning. And I mean, it's probably also unprecedented. And I think I'm basically already too late, because if you ask me, the pandemic is already out of control because of these highly infectious strains. And people may say, some people tell me on LinkedIn, Geert, there is no pandemic. Look, I mean, the mortality rate is still very, very low, et cetera, et cetera. And I'm telling you are right. The worst is still to come. And if we don't stop this mass vaccination, I mean, it's just going to be a huge and incredible disaster.
Okay, so how long do we have in this lull until we should see?
That I cannot exactly tell this,
Yeah.
but it will be fast, because, you know, right now, Matt, things, all the type of curves we are talking about right now, when this surge will start, is exponential. We are no longer talking about linear evolutions or slowly. We are talking about, you know, we have been whipping up this virus, right? You know, to become more and more infectious. And now I don't know whether it can still increase its infectiousness, but I thought, okay, there should be somewhere an end of a level, and then it can break through the antibody defense, and it become resistant to the vaccines. But what we are seeing right now is even worse. It's now really introducing also mutations in epitopes that enable our cellular immune response as a last resort to intervene to save lives of patients who are severely ill.
So not, what are you talking about, months? You're not talking about years, are you? You're talking about weeks and months.
Yeah, I don't even know whether I'm talking about months.
Okay.
I don't think we are talking about months, frankly speaking. Not at all.
Can I ask you this question, just as from a scientific point of view? I want to test these ideas. What would prove your hypothesis incorrect? What are the signs we can look for that we're okay? Is it 3 or 4 months? We're fine. Okay, obviously.
It's exactly the same. Look at those curves. I mean, for example, UK, Israel, maybe there are other countries. I cannot follow everything.
Sure.
But those curves are going down very steeply, right? Because people are very enthusiastic, and now there's plenty of talk about relaxing measures, etc., in the coming weeks and months, etc. If these curves continue to go down, right, at levels where we say, okay, this is like in an endemic situation, then I've proven wrong. But unfortunately, I mean, you see already right now, like in Israel, that they're reaching a plateau. And I looked at the figures yesterday, the day before. There is already a little bit of raise, but I wouldn't say that is significant right now. But the steep decrease has definitely stopped. And you will see the same thing. And, you know, you're asking me, Matt, and it's a legitimate question. What is my scientific evidence? But look, this is the first time we are doing this in the story, you know, in the history of mankind. And we are doing massive vaccination. And we are seeing things that we don't understand. During a pandemic, all of a sudden, a number of highly infectious strains that pop up. People who are, so to say, naturally immunized, because people get natural infection, for example, for the first strain, they are shedding a lot of infectious virus instead of generating herd immunity, etc. Where is the scientific evidence that this is going to have a happy end? It has never, ever been done in the history of mankind. And now we implement this all of a sudden, all over the world, right, with vaccines that are in fact conceived to be used in a prophylactic context. That's another thing you will read in every single vaccinology textbook. Don't vaccinate people whilst they are exposed to a very heavy infectious pressure. So where is the scientific evidence that this, I don't call these vaccination campaigns, I call this one big experiment. Where is the scientific evidence? Where is the scientific rationale even that this is going to have a happy end? You cannot find it everywhere.
Okay,
it simply doesn't exist.
If these vaccines produced sterilizing immunity, it'd be a completely different story, right?
Of course. Then of course it's very simple, Matt. If you have sterilizing immunity, okay, you come with this vaccine, you vaccinate a certain number of people, they eliminate the virus. The virus is still going to continue its course in the other population, but the guys that got the sterilizing immunity are no longer going to be a source of immune escape, at least. So there again, it will be important to do mass vaccination. But what you will have is that you will have sterilizing immunity. So now you can talk about herd immunity, not based on antibodies, based on, I think the only solution are NK cell-based vaccines. Take the example of the virus and educate these NK cells in a way that they can acquire memory. There is sufficient evidence right now, since the last 5 or 10 years, that NK cells can also acquire memory, right?
So now you're moving into the other of the two ways. You're teaching us how we could outsmart this virus.
Well, yeah, I mean, I think it's a logical question. I mean, the reality is very, very harsh. It's incredibly harsh, and we have an absolute obligation to find a solution, no longer to deal with these highly infectious strains, because some people think that these highly infectious strains, at some point we will get rid of them, or they will all of a sudden get gentle enough, friendly enough with us to down tune a little bit their virulence, etc. That's not going to happen. Why would they do this? They have now such a competitive advantage. They're so dominant. So they are not going just all of a sudden to selectively or to select mutations that enable them to be more gentle with us. So in other words, Matt, there is no way that we are going to get rid of these highly infectious variants anymore. So the only chance we have, if we as human beings want to intervene or must intervene, it's to go for eradication of those highly infectious strains. That is really the only scientifically reasonable approach to the current pandemic that has been completely disturbed by human intervention.
How do you eradicate?
Well, as I was saying, you take the example of the virus. The virus gets eradicated in somebody who is asymptomatically infected. And it's not the antibodies that do that. I hope I have made myself clear enough that the antibodies, yeah, right? It is the NK cells. Yeah. And the NK cells, because this is innate immunity, yeah, this is polyspecific, the virus cannot select mutations to bypass that innate immunity, right?
Awesome.
And the NK killer cells, they intervene in these asymptomatically infected subjects at a very early stage of infection. So at the stage where the virus gets into the epithelial cells of the upper respiratory tract, and there it gets killed, right? It's yep. not, it cannot first its way, like in diseased people, to all kinds of different organs and spread through the body, etc. They are killed in a non-specific way, at a very early stage of infection, and it's killing the cell that is infected. As I was telling, if the virus has no living cell, that it can use to replicate, it's the end. It's the end.
But you just mentioned teaching NK killer cells. That are you talking about doing that through a therapy or a vaccine? Because I'm not aware of that ever being done before.
That is how should I say, a particular topic, because I have no commercial interest whatsoever. All this has now become so irrelevant. Let's forget about egos. Let's forget about money. There is only one single thing at stake right now, and that is the survival of our human race, frankly speaking. So, but I must say, I have been working for a number of years on NK cell-based vaccines, and it's not like I'm now making a big noise because I would like to draw the attention to my technology, but I must say it's thanks to my insights in how NK cells work and how they play a critical role in eliminating the virus in asymptomatically infected people that I have succeeded in unraveling what exactly the strategy is of this virus. Because every single thing the virus does is important. And it is even more important if we don't understand this. Yep. So far, yep, we have not understood how it comes that some people get a disease and others don't get the disease, eliminate the virus, do have antibodies, but those antibodies are not eliminating the virus. They are not functional in terms of protecting us. It's the NK cells. So it's the other way around. It's my insights in this technology and in the way how NK cells work and what kind of broad spectrum they have and how you can possibly educate them to acquire memory that have enabled me, first of all, to understand we call this in a complicated word, the immune pathogenesis of the virus.
Yep.
And that secondly have given me some insight into how we could deal with this in a way that we can, first of all, eradicate this, but this would mean that these NK cells need to acquire memory. So by the time we get infected by COVID, by any coronavirus, in fact, remember, it's not variant specific, it's not COVID specific, it's not even corona specific, that we are armed well enough that these NK cells can jump immediately on those epithelial cells that are at an early stage of infection at the level of the upper respiratory tract.
Have you developed such a technology?
Well, it's in early stages. There is promising data, but this is completely going against the mainstream of current vaccinology in a sense that current vaccinology, it's all about B cells and T cells. And people for a long time have said, you know, NK cells, this is innate immunity. There is no memory. We don't understand very well how NK cells work, etc. So it has been impossible so far to move the technology forward in a way that it has been considered, or that it was advanced enough to be considered, for example, to be introduced into clinical trials. Because don't forget, if you come with a disruptive technology, the bar is very, very high. If you have, the bar is very, very high. You know, you come with a conventional technology, people will say, okay, you have an antigen, you show that there is antibodies in mice, and you have a good scientific rationale, and okay, you will get support for this. If you come with something which is so revolutionary, where, you know, the vast majority of vaccinologists don't even know how NK cells work, because typically immunologists have learned a lot from the vaccinologists, but not the other way around. I mean, the science that I'm talking about, I mean, I'm not the inventor of all this science. It is in many, many publications, very, very compelling, convincing evidence. My merit, in all modesty, has been that I'm putting pieces of the puzzle together in order to come to a solution, not to write yet another publication. What we need are solutions. We need people who can put pieces of the puzzle together. This is a very complex story. This is about an interaction that has been shaped throughout evolution between the virus and the immune system, thousands of years. I mean, there is immunology involved, there is infectious diseases involved, there is virology involved, and then you come with a vaccine where you try to influence this. I mean, if you do mass vaccination globally, etc., there's only two things that can happen per definition, because it's huge scale. Either you make the situation dramatically worse, or you improve it dramatically. Now, the latter is not what we are seeing right now, and I'm afraid. I mean,
so your NK cell technology, that sounds like a long way off. Sounds like you're not going to get to clinical trials for 2, 3, 4, 5 years.
Well, it depends. I mean, as I was saying, Matt, I'm certainly not taking advantage of this talk or whatever, you know, to promote or whatever, you know. But
I want to know about it. I'm asking you about it. I want to know how close it is. If it's a year away or 5 years away before.
It depends. It depends. It depends how dramatic the evolution will become. I think it will become very dramatic. And I'm telling you, if things come dramatic, we may be back to a situation like where Jenner administered his vaccine, his first vaccine, to eradicate human pox virus. So what I'm saying is
what happened. I'm not familiar with that story. What are you
well,
referring to?
this is the first vaccination. I mean, Jenner was. This is the guy who used cowpox, in fact, to eradicate human pox virus. So the other thing is that, per definition, as you know, antibodies are just attacking or capturing circulating virus, right?
Yes.
The big advantage of cellular immunity, I'm now talking about a kind of innate cellular immunity, is that they attack cells that are infected, right? So that means that when a cell, if you use antibodies and the cells are infected, you cannot destroy those cells. I mean, you can destroy the virus, but infected cells, same as, for example, with cancer cells, right? We have no vaccines against cancer cells. We are good at generating vaccines that induce antibodies, and that the antibodies can capture a free-floating virus, so to say, or a free-floating antigen. We are not good at making vaccines that can destroy
the cell,
infected cells, or in general, pathologically altered cells, right? So now if you imagine, if you have a vaccine that can do this, you may even think one step further, namely of intervening in a disease process that is already ongoing, where cells are already infected. Yeah, well, also people who get COVID disease, who have already the disease.
Yes, well, even at a less spectacular level, you're talking about a technology that could cure the seasonal flu.
Well, no, as I was saying, I mean, NK cells are polyspecific.
Yeah.
So you may even think of NK cells that could, but I mean, I'm not very eager to tell this, not for IP reasons or whatsoever, because none of this is important anymore. None of this is important. It's about us. It's about humankind. But it's so far from what people are able to believe. And it's very strange to me, because I was mentioning the parallel with antibiotics, and we find it perfectly normal that one antibiotic can kill several different microbia that are phylogenetically not even related. They are not family from each other. One antibiotic can kill a huge diversity of several. We think vaccines, it's not possible. We cannot make vaccines that at the same time could, for example, destroy corona and influenza, for example. And I'm saying, if you make NK cell-based vaccines, it is possible to do this, because the vaccine is, we call this antigen non-specific. It is polyspecific. So it is, in fact, directed not against a specific antigen, but against a pattern of motifs, a repetitive pattern of motifs. And that is also, that also explains why people who have, for example, blood group O, right, where there is a number of motifs that are similar to motifs that are expressed by cells that are infected with COVID. That is why these people are better protected against COVID than people who have other blood groups, for example. All this is in the scientific literature. It's just that we don't take advantage of these publications. As usual, these publications end with, this could be very important for vaccinology. This could be critical knowledge for vaccinology, and nobody is using this, right? And that is the piece that is really missing. It's not that we cannot do this. I'm convinced we can do this, but we need to make it to make a priority of it, right? I mean, you have seen these vaccines that I'm talking about, an NK cell vaccine, frankly speaking, a very short construct, and I'm absolutely not boasting here. I have no interest whatsoever. My only interest, I'm an independent consultant. My only interest is, to come and to foster a solution that can, prevent us from a huge disaster. And what I'm saying is that this type of constructs could be synthesized, millions of doses within just a few months. That is even very different from the current vaccines. We talk about mRNA vaccines, etc. It's very fast. It's much simpler than the conventional manufacturing technologies. And you have seen, even though it's still pretty complex and complicated, these companies have managed to do this within just a few months. Now I'm talking about a construct that is way simpler. But I'm not saying right now, Matt, that there is proof of concept, of course, but there is no clinical data. There is no trials that have been conducted with this construct. But it's all a matter of prioritization, as you very well know. When these mRNA vaccines, they were in an experimental stage almost, and all of a sudden, they got advanced and moved forward into clinical trials. 1, 2, 3. It all happened very, very fast. So it's a matter, of course, of prioritization. And again, I'm not my technology. I'm saying, for God's sake, take the example that the virus is showing us, how you can eliminate it completely without inducing immune escape. And the path points to NK cells. That is my message. It's not about me. It's not about my technology, not at all. I'm just saying it's thanks to my insights into this that I managed to unravel how exactly the pathogen is, subverting, misleading our immune system.
And Geert, is there any support out there? Is anyone prioritizing this kind of research, like private companies? Governments are going to be very slow, obviously.
Yeah. Not right now, of course, Matthew. I mean, I have always said I always thought, well, I'm probably, in all modesty, I come 10 or 20 years too early with this technology because it's just not in the mindset of vaccinologists that you could make a vaccine that could be just as our natural NK cells are, that our natural immunities, that is multi-specific. It's just not in the mindset, right? And so I'm always was prepared since, I'm no longer a naive person. I'm no longer 25, unfortunately. And I mean, I've seen all the different technologies I've been exposed to, and that is at some point in time in my life, I said, look, I mean, none of this is good enough. Today, we don't have therapeutic vaccines. We don't have vaccines against cancer. We don't have vaccines against chronic disease, et cetera, et cetera. Basically, the majority of our vaccines are antibody-based. And we have been doing a marvelous job with those vaccines. Let's be very, very honest. But we have reached the limit of what we can do with these vaccines, right?
Yeah, but hang on. The mRNA vaccine is a therapeutic. It's simply a symptom suppressor, right?
No, it's not a symptom suppressor. The mRNA will ultimately lead to the synthesis of the spike protein, and the spike protein is going to be taken up by antigen-presenting cells, and there you have the same story as if you would inject the protein right away. I mean, that is in very simplified terms. But mRNA is, of course, used also for therapeutic approaches. I mean, but we are talking about the COVID vaccine, right?
Is there what about natural approaches to increasing innate immunity? Because there's already a lot of talk around increasing NK.
Well, Matt, you are touching upon a fabulous question. I mean, I'm so glad I've forgotten about this, that you asked this question, because indeed, what is critical, I mean, it is very well known, it's documented. And if people like to have the publication, I can send them. I'm not telling anything which is not based on direct or indirect scientific evidence. It's just that in all the things that I posted right now, I didn't even have time to look and for all these publications, etc. Because what I'm sending out right now is a scientific alarm. It's not like a manuscript peer reviewed. We have no time. But back to your question, it is very well known that people who are in good health, in good shape, have a strong innate immunity, have strong also IgM responses, antibody, which is a major part of our immune globulins, and these are the natural antibodies actually. So that means that one thing that I've not seen during this COVID crisis is an appeal to people, to conduct a kind of different lifestyle. I mean, things we all know it's good, but we underestimate the huge impact this has on our innate immune system. Things like, exercise, very important. I've not had a chance, I don't know whether they even exist, to have a look at the statistics of COVID infected and diseased people who
I have a huge correlation between metabolic in the US. This has been through a few doctors. One of the more popular ones has been Dr. Paul Saladino, who's been pushing some studies on correlation between metabolic syndrome and bad outcomes with COVID-19. Another one was Dr. Rhonda Kirkpatrick pointing out low vitamin D levels having lower innate immunity and then perverse outcomes. So there is data.
That is just one example, but I'm also talking about, and I'm a scientist, right? I mean, I'm not like, in nutrition, etc. But healthy food, critical. Have enough rest, right? Have enough sleep. Be stressed, but positively stressed. Have a good mental attitude. I mean, what I'm saying here is that there is increasing evidence through an incredibly fantastic discipline, neurosciences, what the impact is on our brain on the immune system. There is increasing evidence that there is, and I always give the example of a mother that is taking care of her infected child, a child that has a severe infection. The mother is not going to get illness, despite the fact that she's treating all the time this child, right? You have a very important deadline, Matthew, and your career depends on it. And you are feeling like, oh damn, I'm gonna get a cold. You will be able to suppress that cold till you have achieved that. Yeah. And in the past this was all like science fiction, and now there's increasing evidence that there is neurological paths that can explain this. And so this now becomes so important. All these things, stay away from toxic influences, alcohol, drugs, smoking. This doesn't mean that you shouldn't drink a beer, right? But try to avoid abuse of all these things. And there is despite the fact that the single most important part of our immune system that we should conserve, throughout this pandemic is our innate immune system. There is no calls to the people, or barely any, to take care of their health and to have a good lifestyle, etc. And the most important thing I would like to convey is that the most dramatic thing that could ever happen is that our younger people get vaccinated, because they have a very mighty arm of the immune system that is polyspecific, that can deal with any of these COVID variants, which is the innate immune response. And if we are going to vaccinate them, these antibodies are just going to suppress this innate immunity for a long time, because those antibodies will stay for a long time. It's not like you're asymptomatically infected, where the antibodies disappear after a few weeks, maybe. They're going to experience a suppression of their innate immune system for a long time. And you could say, well, yeah, but who cares, because they have specific antibodies. I'm telling you, and I mean, I'm 200% certain of this, that it's just a matter of days or weeks till we are going to see increasingly resistance of these variants to the vaccine. I mean, the evolution, there is already so many mutations in the spike protein that it suffices for the virus to just add maybe 2, 3, I cannot say exactly, mutations to the specific domain that is responsible within the spike protein for attaching to the receptor on the susceptible epithelial cells for this to happen. And then what then happens is that you can throw your specific antibodies in the bin, and your innate immune response is completely suppressed. And that is what we are currently, planning to do with our younger generation. That is, the heart of our society, right?
So do not vaccinate our young people, and look after your innate immune system. They're the two key things. Yes.
Yes, and we need to protect. We need to protect the people who are vulnerable. I'm the first to say this, of course, because these people, they will have antibodies. If they survive, they will have antibodies, right? And also elderly people who have been vaccinated will have antibodies. And when, of course, these antibodies are no longer functional, they become very, very vulnerable. Right. That is clear. So we need, and that has nothing to do with discrimination, because even younger people who have an underlying disease, could be subject to this. But we need to distinguish from an immunological viewpoint between two populations. This is the population that is susceptible to disease, right? To COVID disease. And when I mean disease, I'm always telling about severe disease, because in all the papers that I'm posting, in all the communications, I talk about disease, which is meant to be severe disease. And I'm talking about asymptomatically infected, right? Which means maybe mild symptoms or no symptoms at all. But immunologically speaking, it is critical to distinguish between those both populations, and the virus is dealing with these populations in a completely different way. I hope I explained this during this talk, but this is for me a key message. Please don't vaccinate our younger people. And, if people are very vulnerable, I mean, we need to be very, very careful, because these people, if you vaccinate them, but there is resistance, I mean, they will have, of course, no benefit from these antibodies. Their innate immunity may already be suppressed, may not make a big difference. Therefore, I'm saying all those that are vaccinated, have already been vaccinated, or people who have gotten the disease, got the illness, and mounted, antibodies. Those people will be, because of the suppression of the innate immune response, and because of the high likelihood that the resistance is going to occur very soon, or extremely vulnerable. And we need to do whatever we can to protect those people. But the measures, I'm not proposing any measures right now, but we need to rethink what we are doing very urgently, and not based simply on curves that we are looking at, like at the stock market, but based on science, based on the immune pathology of the virus, based on the understanding of a pandemic. And that is the only way to move forward. And that makes not only scientific sense, but it is an absolute, if we are committed to perpetuate our race, I mean, we have to do it, to do something, not in a week, not in 2 weeks, but yesterday.
Okay. And thinking at the population level and this whole problem of immune escape, are there any populations that you think we should still vaccinate with our current vaccines?
No.
Okay.
Absolutely not. Absolutely not. And we will see, Matt. I mean, this is maybe a little bit too far in future, but if this, of course, continues, we will see huge changes in, you know probably, or you can guess in which countries, in which continents people have the best innate immunity. It's certainly not in Europe, right?
No. There's been some astounding results in Africa and places like that. Can I ask you? Yeah, can I ask you about? I came across you because of Professor Nikolai Petrovsky, who I interviewed. He's a vaccine creator. He uses recombinant protein vaccines.
I know.
If he succeeds in bringing out, and others as well, bringing out sterilizing immunity vaccines, probably based on recombinant protein methods, will that fix the problem here? Is that a potential way out? Because they're talking about the end of this year having sterilizing.
Well, any vaccine that indeed would enable or induce sterilizing immunity would be a game winner.
Yeah, sure.
But it's my conviction that it's not possible with the conventional methods.
Because they won't be able to keep up with the mutations.
Based on antibodies, it's not going to be possible.
Okay. What do you think of, I don't know if this is directly related, but what do you think of other therapies that like ivermectin and things like that? Is that having any...
well, I have at some point looked into this, but I thought it was quite promising, but frankly speaking, I mean, I will not voice any opinion where I'm not a deep expert. I consider myself as being a deep expert in vaccine design and in unraveling, interactions between virus pathogens and the immune system. I've read about ivermectin, and my recollection is that I thought, well, this looks really very, very interesting. But I must say, I'm not a deep expert. And right now in this crisis, there is only one discipline that must prevail over anything else, and that is science. So we don't need the advice of the type of scientists who are sitting in these TV shows all the time, right? We need the advice of people who day and night are, trying to understand the problem, or doing really the research, have a deep understanding of what is going on, rather than, maybe some advisors who are caught all the time in TV shows, etc. I mean, this is it's not helpful any longer.
Let me make my question more specific to what you've brought up. I'm wondering whether therapies like ivermectin and hydroxychloroquine contribute to the problem of immune escape that you've described or not. I'm just wondering if they're contributing.
I don't know. I'll be very open with you, Matthew. It's certainly 2 months ago that I took a deeper dive in some publications on ivermectin.
Sure.
But it's only quite recently that I have gained very, very clear insights into all the opportunities the virus had to escape to the immune system. I've not had the opportunity to connect both elements so far. So I'm not going to tell anything that
Sure.
I'm not really, that I don't know the detail of.
Okay. I just got a couple more questions for you. Can you teach me about the difference between influenza and COVID, in the sense that the innate immune system somehow prevents all of our young people from being susceptible to COVID-19. However, our young populations are still very susceptible to influenza. They're both coronaviruses. Both should be solved by the innate immune system.
No, they're not both coronavirus. It's a paramyxovirus, the influenza. So it's another type of virus.
Oh.
Influenza is another type of virus. Yeah. But again, I mean, the same applies. Good innate immunity is key. But good innate immunity means, either you're a child, you're a young kid, or you are an adult, or even an already older guy like myself, but you keep your health in very, very good shape. Of course, for industry, that's not very appealing because you cannot sell this, right? Mm-hmm. But it is a key thing. It's a key thing. All the elements I mentioned, and you don't have to score like, to have a triple A for each of these parameters. Mm-hmm. But if you have an average, on a scale from 0 to 10, if you have an average of 8, I'm not saying you're protected against COVID, of course, but you are in much better shape. And don't forget, there are also, of course, unfortunately, young people who have an immune deficiency, right, of their innate immune system. Yes. These people will, of course, be susceptible, despite maybe a healthy lifestyle, etc. And we need to take care of these people. We need to identify them, not to stigmatize or whatever, because the thing that will become incredibly important right now, right, is solidarity, right? And solidarity and our health and saving our human race. I mean, all the rest is now becoming so irrelevant, right?
Geert, is there anything that we didn't cover that you wanted to talk about? Anything
no. Well, this, we could go on for hours and hours. I mean, it's like once you have put these pieces of the puzzle together, you have unraveled this. I mean, there is now so many things that become clear to me. There's so many things that I can explain that remained unexplained so far. I've even never heard somebody explaining the three waves, you know, during a natural pandemic. What exactly do they represent? How exactly, you know, does it come that all of a sudden now the young people are affected, etc. And you know, this has now provided me with many insights that I hope, I really hope that I can help to do something as urgently as we can, because it's 12:05. Unfortunately, we have these highly infectious strains out there, and we are not controlling them, and the immune pressure is just increasing.
Okay, so
yeah.
Let me ask you this final question. From your expert perspective, what would be the absolute best way from here over the next few weeks and months? What would be the best case response for us, for governments and for everyone around the world to take? What would you love to see happen?
We first need to immediately stop the mass vaccination. I mean, that is very, very clear. Okay. And then we have to see what we can do about our young people, because right now also, well, in Belgium, and I guess in other countries, what we are seeing, of course, is that increasingly young people are now also, younger people are getting the disease. And of course, so far, I guess, but we will be very cautious, because I'm not, of course, aware and informed about all the details. But I'm under the impression that right now it's primarily the younger people who do have a problem. And we forgot to say that one of the biggest problem, of course, we forgot to mention this, and young people need to do something about this. It's obesitas, right? Obesity. People, etc. Yeah, obesity. Yeah, and or people with diabetes sometimes as a consequence of obesity, etc. And but of course, the more we will prevent the virus from going elsewhere, it will take a higher toll on younger people. And we cannot rule out that ultimately there is even young people without underlying disease that are going to succumb to disease or the infection. So what is very important, we cannot determine, unfortunately. I mean, that is really very, very early days. People have tried to do this, is to determine what is our level of natural antibodies, right? That seems very difficult to do. But the smart thing, I think, to do would be, well, we know that even if we don't know exactly what is the level of our natural antibodies, there is something that we can measure and that we know is suppressing these antibodies, is outcompeting them. And that is, of course, the specific antibodies that asymptomatically infected people are acquiring. When they have these antibodies, I told you all the time, then they become susceptible. So it may be a good idea to give more freedom to our young people, provided they are seronegative, because then we know at least their immune response is not suppressed. And I think we should work on making this quick diagnostic tests, fingerprint, etc., to very reliable. I don't know what the reliability of this test is right now.
So serum negative
and things like this.
Yeah. So when you say serum negative as opposed to PCR negative.
No, I'm not talking about the PCR. I'm not talking about the antigen. I'm talking about the antibodies. Yeah, because if they have antibodies, we know that their innate immune system is suppressed.
In the serum, in their blood.
In the blood, yeah,
yes,
in the blood.
Yes.
And so this is just a few things that come to my mind. But frankly speaking, as I told you, of course, stopping mass vaccination, that is very, very clear. And stopping to lock up our younger people, especially, or all people, I would say, who are in good health, in good shape. We need to stop that, but we need to be very careful, because highly infectious strains are circulating. The likelihood that you are getting seropositive, now you understand what I mean, that you're getting seropositive is becoming pretty high. But if you could do a quick test and you see you're negative, for example, if you're positive, please stay in your home, stay at home, right, till you're seronegative. We know that the duration of this antibody titers is very short-lived, right? It's not like you're going to stay home like for weeks and weeks, right? And that might be an intelligent strategy to keep up, or to keep in good shape our innate immunity, together with a good lifestyle. Explain what this means for young people to still have at least their innate immune system in very good shape. I think from all my explanations, it has been very clear. The worst thing to do would be to get a vaccine, because that is going to suppress this innate immunity for a long time. I was telling about those who turn seropositive spontaneously without vaccination. That's only going to last for like a week or so, maybe 2 weeks, and then it's gone. Right? But if you get vaccinated, I mean, this is long-lived immunity, right? So that is a different story.
Geert Vanden Bossche, Geert, thank you so much, because you often made a comparison during this interview between you and the establishment vaccination elite, but you are that is what you've done for decades. You have been at the forefront of vaccinations. You're a big believer in vaccinations. So your warning to the world right now carries an incredible amount of weight, because you are the furthest thing from an anti-vaxxer, and yet your warning is you've been building vaccines forever. And
I'm saying these vaccines, the vaccines that are out there, have been made by fabulous, brilliant people. And of course, there is discussions about how efficacious is it, 85 or is it 92, etc. And could there be some side effects, etc., etc. Okay, I mean, certainly there is always some concern if you have only clinical trials that have been conducted over only like 3 months or 4 or 5 months, etc. But, there was an emergency, there was no choice. So I think those companies have given the very best of themselves. I've been working in those companies. I know how difficult this work is, how precise it is. It is brilliant work. The only thing, and at the end of the day, the regulatory bodies have approved them, right? I mean, they have a responsibility for the public health. The only thing that I'm saying is that this type of vaccines are completely contraindicated for use in a pandemic, right? And that is, so I'm not an anti-vaxxer, because I'm even saying, I think the only way, if we don't want to let the pandemic go its natural course, which I think is difficult to justify at this stage, because we have this highly infectious strain circulating. The only thing that would make sense to me is to mimic the strategy of the virus and to make indeed vaccines and to do vaccinations, but with another type of vaccines that are capable of eradicating the virus and that provide sterilizing immunity. So, okay.
Well, this is why your voice is so credible on this matter, and we need to take your warning very, very seriously. So thank you so much for coming on and explaining for the last couple of hours with us.
Thanks, Matt, for having me, and I really hope that my message resonates with those who have the responsibility and also the authority to change things fast and very dramatically, I think. Yeah. Thank you so much as well, Matt.
Thank you, Geert. Godspeed.
Bye-bye. Thanks. Bye.